Hello and welcome to the Oxford MAT Livestream. My name's James. Today on the Oxford MAT Livestream, graphs and transformations. Let's start with some maths, as always. I'm going to talk about a couple of transformations of graphs that people find really tricky, and we're going to talk about how we're going to get it right every time. Okay, here's the translation that people find tricky. It's the one where you start with y equals f of x, and then you want to know, so maybe y equals f of x looks like this or something, and then you want to know y equals f of x plus 2. Now, some of you have learnt this very carefully. You know what's going to happen when I do y is equal to f of x plus 2, kind of different graph to sketch. Maybe I'll put some numbers in. Maybe I'll say on my original graph, this is 1, this is 2, this is 3. Okay. So, hopefully you have already seen something about transformations and translations, and you've got an idea about what might happen. People are joining in chat. Peter and the person using the username Nikita Mazabin have both told me this is a translation 2 units to the left. There are different ways to say left, by the way. I find left and right very tricky. Sometimes people say 2 units in the negative x direction. This is x, positive x direction being positive, negative x direction being leftwards. Zach's got that as well, and George as well. George has given me a vector for this as well, which is exciting. I like being told what to do with vectors. Here's one way that I use to get this right, which is to imagine, like we always do with curve sketching, imagine what happens when x equals 0. So when x equals 0, this new thing, the new curve, will give me f of 2. F of 2, the original function, that was having some sort of minimum thing near 2. In particular, the value of f of 2 is down here somewhere. So I just draw a bit like that. And that's how I remember that, oh, it's taken this bit of the graph and moved it left. Because when I put in the number 0, I'm accessing not what the original function was doing at 0 or minus 2, but what the original function was doing as if we put in 2 instead. So I think this is going to end up looking like this. Yeah, okay, so this feature over here is now, ooh, that's not gone very well, has it? This feature over here is now 1, this is now 1/2. It's not the best picture in the world, but hey, there we go. Okay, welcome to the live stream, everyone. Welcome to the Oxford MAT live stream. It's great to have you with us if you're watching live or if you're watching the replay, either way round. Great to have you here. Quick shout out to people in chat. I can see Sam Bronwyn, anonymous person here as well. If you're joining the Slido chat live, we're at slido.com/matlive. You can put a username if you want to, but you don't have to. You can even put in a name like Loki. Maybe that's Loki's real name. Which is cool name. Cool. Good. Yes, Loki's got a vice. It kind of means, oh right, okay, there's a whole paragraph. Whatever's in the bracket, you do the opposite to x if it's inside the brackets. I have mixed feelings about remembering it like the opposite. It's sort of one more minus sign to remember in your head, right? So if your mnemonic for this is it's the opposite of what I think, then that gets very confusing if you've got lots of mnemonics like that. Hi to Anise, hi to Asdurf, hi to Georgie. Georgie's actually here live. Hi, Georgie. Hi to people from Unique. If you've been on the Unique Summer School and you found out about the Mat live stream and now you're watching one of these as well. Cool, good. Hi to anyone I've met on the... I've been at a conference today. If I told you about my live stream today at the conference and you're here after the conference, ha! Nice to see you again. I would like to talk about the suggestion in chat of f of ax plus b, which I suppose is made of 2 steps. Maybe we should talk about doing 2 steps. Let's do another step here. Hi to Lena and SV again. Anonymous person and Anipa. Right, cool. Let's do a second step. I'm going to pick a different one though. I'm not going to go for ax plus b inside the bracket. Although I'd probably approach that by checking what happens at 0. That'd be f of b, and I'd try other numbers in there. I think I'd now like y equals f of 2 minus x, using this same function. So, can we work out what that's going to look like? It's a very wobbly diagram, isn't it? It's a very I'm going to go as far as a bad diagram, but hey, we changed the labels, we made it work. What's this one going to be like? So this 2 minus x inside the bracket, it is not one of the basic transformations that you might see on the MAT syllabus, which we're going to look at in a moment. But this transformation, I think I can make it out of 2 steps. So some people have seen this at A level or equivalent. I think people are talking about mirror images of things. Yeah, so Nikita wants to do it as 2 steps. Yeah, so something about, there's some themes in chat here, coming up here, I love it. Some ideas about reflecting. Ooh, ideas about reflecting something, and ideas about translating. And we've got to be careful because it matters what order we do those in. Symmetry along the y-axis. Does along the y-axis mean up and down? I'm a bit worried about that. Oh, symmetry as in reflection. Be careful, when you say symmetry, there's lots of symmetries you might mean. I think you mean reflection, but you should probably say reflection rather than like a rotation symmetry or some weird shear symmetry. Oh, is it minus f of x minus 2? I'm not sure it is. Maybe it's true that f is an odd function and that you can pull out a minus sign like that, but maybe not. So people are giving me steps now. Flip the f of x function and then translate it by 2. Ooh, maybe that. How do I feel about that? Flip it and then translate it? Possibly. Yeah, okay. Yeah, so I guess there's 2 approaches here. Maybe I've picked weird numbers. Two approaches we could use. Yeah, people are putting really good explanations in chat. This is brilliant. We are doing the poll, don't worry, Sam. Try checking values. I love that. Try checking values to see what happens. This has got the same thing going on. When x is 1, this gives f of 1, which is the same thing as, you know, if we put 1 into the original function. That's pretty nice. Okay. People are thinking about maybe doing this like f of minus x plus 2, I saw. That gives you one way to think about it. Maybe do this first and then switch the x to minus x. That's what I was personally thinking of when I wrote this down. So some sort of reflection in the line x equals 0. But some people I could see were thinking of this as f of minus x then plus 2. I don't really have good brackets to suggest this, but doing the things in that order instead, which would be flip the original graph and then translate it. Okay. And some people have suggested that all of these are just a reflection in the line x equals 1. Brilliant. Okay. Reflections in the line x equals 1 are not on the MAT syllabus, but you can build them like this by doing something like that. Okay. Seems good. People have given me great suggestions for what to do. Factoring out the minus 1. Yeah, I'll write it on the board. Minus x minus 2, like that. That's sort of a different thing, isn't it? Sort of do the translation and then do a translation in the opposite direction and then flip in the x-axis. I guess that works as well. Cool. And hi to Manuel. Right, okay, let's turn on the poll. At the start of each episode, we like to run a poll. The poll is a 5-star rating. How do you personally feel about the topic of today's session, which is going to be graphs and transformations? Thinking in particular about this sort of content, about what the graphs of quadratics, cubics, tan, root x, all these functions, all these different things look like, and think about transformations as well. Maybe doing some inequalities and equations and inequalities with graphs as well, but not too much of that today. So thinking about how do you feel about that, where 5 stars is very confident, this is one of my favourite topics, 1 star would be no, I don't understand this at all, it doesn't make any sense to me. Thank you for voting in the poll. Oh, look at that, there's some voting. Can't see chat. Yeah, so a question's come in before, how do I know it's a reflection in x equals 1? And I suppose it's because the minus x going to minus x is a reflection. So I think this is some sort of reflection. And then I'm working out which point hasn't moved. So the number 1's special because 2 minus 1 is equal to 1. So 1 hasn't moved, that point. So some sort of reflection and 1 stayed the same. Feels to me like a reflection in x equals 1. And in fact it is. You do a little bit of algebra to check that that's, if you write down what a reflection in the line x equals 1 actually should mean, then that matches up. Okay. Yeah, some people. Okay, I wonder whether people's feelings about other subjects are coming in here as well. In fact, there is a logarithm on the screen. In the YouTube description, I've called this a kind of crossover episode because we've got lots of other stuff going on, right? We've got sine, cosine, tan. They've come back again. We haven't had the logarithms episode. That's next week. But if you're watching this in the future, then this is like a crossover with a future episode on logarithms, which some people are a little bit worried about. But overall, we've come out at 3.7 on the star ranking, which is pretty good. Pretty good at the start. Right. Okay. I'm going to turn that off so that we can see chat again. We have to have one or the other. Right. Cool. Good. Someone's asked my favourite graph. I'm going to try and not get off topic yet. Good. Also, I don't have a canned answer ready. Okay. Good. Somebody would like the chat section. Does this make sense to everyone else? Someone would like the chat section on the end onto Spotify. Oh, the bit at the end where we just talk about stuff. Huh. So people have noticed the runtime of the episode is like officially 1 hour of MAT Livestream, but then there's some rambling chat afterwards. So one person, I know, somebody's given it a thumbs up. 2 people would like that on Spotify. Which is frankly terrifying. Right, okay. We're going to skim read the revision material. If you would like to have a closer look at this, it's on the worksheet. There's a link to the worksheet on the Mat Live homepage, which is down there, math.ox.act.uk/r/matlive. Also linked in the YouTube description and in most of the places that link to this, hopefully also links to the worksheet. If you would like to think about graphs of quadratics or cubics. I've also got graphs of sine and cosine and tan, which is a nice practice of sketching those. Sketching these graphs is quite interesting because you sort of immediately have to think a little bit about, there's some interesting points where these are equal to each other. Am I getting those in roughly the right places? There's some interesting questions you can ask yourself, having done the description. Like when I draw this, I've drawn tan bigger than sine. Is that true? Is that actually true? Are there maybe some numbers in between where tan is equal to sine? Or does it overlap a bit? Or is it definitely true that tan's bigger than sine? So I've put that in. There's some questions you can ask about that. They're kind of related back to the trigonometry stuff and the inequality stuff and solving equations. Brilliant. I love graph sketching because it links into so many other things. Right, more pictures of graphs, and then I've got my notes on translations. I've tried to write these as translations in the positive x direction, in the positive y direction, to make it really clear about which way I'm going, in case people don't like left and right. And some stretch factors. The stretch factors have a kind of similar thing going on, that if the a is inside the bracket, it's the opposite of what you think, which is how I told you not to remember it. A better way to remember it would be plug in x equals 1 and see what the thing is doing. Okay, and hi to Molly, who's here as well. Riser says, graph transformations are cool because initially you have no idea of what the transformation will be when there are multiple transformations. Yeah, you can make things out of multiple transformations. Okay, there's some warm-up material. I'm actually going to skip most of the warm-up material. I think you know if you need this, if you want to practice doing some warm-up problems. You can get these each week before the live stream. They're posted. They're all there now if you want to get the warm-ups for future weeks. If you want to do some practice sketching, some quadratics in different cases, I've given you 8 different cases to sketch. I think it actually turns out to be 16 different cases, because in some cases there might be roots or there might not. So I think it gets up to about 16 cases, maybe. So this is a completely evil warm-up question where it's just me. It's like if I made you do a lot of press-ups or something. It's just completely evil. Sketch me all of the possible quadratic pictures that you could draw, all of the possible ones, right? Good times. George has got an answer. George's answer. The trig thing is using gradient, and the gradient of sine and cosine is not on the MAT syllabus because differentiating sine and cosine and tan makes more sense in radians. We're not using radians on that. Anyway, I guess I'm saying don't worry if this doesn't seem like maths you've learnt yet. Cool. Yeah, about 16 cases, isn't it? Good. Good. Arm workouts. Also doing some translations, doing some easy messing around. I put in a couple of points in the warm-up for you to check, having done your sketches, to check that the order you do the transformations in can matter. So here, this is something like, or even, this isn't even the order of the transformations, this is just having similar looking transformations in different places, putting a +1 inside the bracket or outside. I should have done some different orders of transformations as well. I guess this sheet was long enough already. sketching some other curves. Do we want to talk about these? Do we want to talk about any of these? Question option time. Do we want to talk about any of this? I'm not sure. I tried to put some practice in at the bottom for sketching all the points that satisfy some equation. Because as well as sketching functions, I think we can sketch solutions to equations. It's kind of subtly different, isn't it? When you sketch x squared equals 4 minus y squared, all the points that satisfy that, what you're actually doing is finding all the points in xy coordinate plane, all of the points that satisfy that equation, and it turns out to not be a function. Y is a function of x. Turns out not to be a function because there's multiple values at some values of x. Right. What does changing b do in the graph? Changing b changes the gradient at 0. It changes whether, you might know that a positive looks like this, a negative looks like this, c positive means that it goes through a positive point on the axis, c negative means it goes through a negative point. B positive, Todd's asked about, B positive means that when it goes through that point at the origin it's going up. B negative means when it's going through a point it goes down. That might be above or below depending on whether C is positive or negative. There's all these different cases. But yeah, A tells you about the curvature, B tells you about the gradient at 0, and C tells you about the value at 0. Cool, good. The last one there was a circle, yes. And they were secretly straight lines, parabolas and circles down on these expressions. I'm hoping I caught someone out. I'm hoping that there's someone who thought about this long and hard and found different numbers that satisfy it and then spotted it was a circle afterwards. If that's you, then great. You have to do more warm-up. Good. Will I allow Desmos? People calling it out as a circle. Also, a shout out for Slido dark mode in chat, which is nice. They put dark mode in about 6 months ago. It was brilliant. Peter's got an answer for the root 2 question. I think I'm going to leave the root 2 question. I mean, Peter's put an answer on screen, but I'm going to leave the root 2 question. We're going to talk about proof and irrational numbers later on. And somebody would like me to talk about complex numbers again, and once again, I'm not going to talk about complex numbers. Oh, Ellie would like 1/2. Yeah, 1/2 of. Yeah, let's do the 1/2. I see people get this one quite a bit. Okay, so cos 2x means take your graph of cos x. People who have seen the live stream know that I don't leave enough space when I draw things. Take your graph of cos x, which looks something like that, up to 360 degrees, and then it repeats. Cos 2x says, well, it's going to do all of that by the time we get to 180 degrees, because when I plug in 180, that gets doubled, and it'd be like doing cos of 360. After that, cos repeats, so I'll see the same thing again. So that's my cos of 2x. The idea of this next bit is that it's two transformations. There's a 1/2 at the front here that's squashing this down, so that instead of going between 1 and -1, if you put a half at the front, it'll wobble between 1/2 and -1/2. And then, so you've got that thing that's wobbling between 1/2 and -1/2. And then add 1/2 to all of that, like add 1/2 to all the values, translate it up, and instead of wobbling between 1/2 and -1/2, it'll oscillate between 1 and 0. Well, that's 360 degrees. I'm saying oscillate a lot because I like thinking about kind of physics in a way, which I know, burn the witch. But having this thing that's oscillating a little bit between 0 and 1, thinking about the range of values that it can take, I suppose, is helpful to me for thinking about where it's going between. Okay, what was I trying to prove last time? Loads of things. Oh no, that's Rilo asking B. Cool. Yeah, it was a sort of special parabola. Anyway. Yeah, and people. So this one is sort of a bit of an in-joke, maybe. This is. It turns out. So this is a secret. Don't tell anyone. But this is equal to cos squared of x. That is not a fact that you need to know for maths questions. But it is true. It's cos squared. Interestingly, People are quite bad at sketching cos squared x. So cos squared x means take the graph of cos x and square all the values. People are quite bad at drawing that. Sometimes even when they know this secret fact. And if they know the secret fact, then they should be able to make it out of these steps and get to the graph. But people still find cos squared x really hard to draw. Did I say wobble? And people are now going to call me out for saying wobble. Yes, okay, so people saying it's cos squared. Yeah, so my PhD was in fluid dynamics. Fluids do oscillations and wobbles. Right, cool. Good. People know about sine and cosine. So you don't need to plot. Okay, people trying to get complex numbers in again. Do we need to plot x negative if it goes complex over there? No. Just plot it where it's defined. If it's logarithms, plot it where the logarithm's defined. Okay, good. Right. Some people know about double angle formulas. Not everyone knows about double angle formulas. Good. Okay. Sorry. Is it even a MAT livestream if somebody's until somebody mentions a link to complex numbers? Brilliant. SV's got a good question. How do you judge when to find the minima and maxima? Sometimes the mark scheme wants it, sometimes it doesn't. It's tough, isn't it? Often, so what I'll barter with you, often finding the maximum and minimum of polynomials, if it's not too much work, if you know all the coefficients of the polynomial, it's like just something that you could quickly work out, if it's quite a simple polynomial, then it might help you understand what's going on, even if you don't officially get a mark for it on that particular mark scheme. If they ask for it, then they want it. Otherwise, I'd probably not find maximum and minima, just because it's a bit of work, right? You've got to differentiate to find the equation where the turning points are, and then you've got to plug in 0 and solve an equation. It feels like quite a few steps. If I'm asked to do it, I'll do it. Something changed when I became a PhD student, which is like doing maths with a stipend. It's like they're paying me to do maths. You know, you want me to do maths, then well, from now on you gotta pay me to do that. Right, cool. Yeah, so you can have a calculation in your GCSEs, but then not in your maths test. Yeah, Josh is in for finding turning points, and it was 3b1b. It was a circle at the end. Yeah, sorry, I phrased it like a complicated question. It was actually a circle. Okay, we've got a choice now. There are some short questions. I think the first short question is very tricky. The second one's quite nice, and the third one is over here, is huge and not too bad at all. I think I'd like to talk about the huge third question, and then the long question, and then come back to the other two. Okay, we're going to try and get lots of things done. Let's go. I can't get all of this on screen at once. There we go. Good. Okay, I'll turn on a poll as well. Hide the results. 2017 1D. Okay, questions on screen. Sorry that isn't really fitting on the screen very well. The diagram shows the graph of y equals f of x, and the thing we're asked for is the graph of minus f of minus x, which is a little bit of a complicated thing to work out. We're going to need to have an idea about how to construct that from the graph of x. We don't have an equation for x. I'm trying to work out how to turn chat back on at the same time as talking. Give me 2 seconds. Would really like chat. Aha! There we go. I got chat back. Okay, we zoom back in. I fixed a visual bug on the stream. So previously the top comment, it was annoying me. The top comment didn't have the rounded corners, but now it does. Fixed it. So somebody's asking for tools to understand propositional logic, which is a really complicated thing we learn in 3rd year at university. I think there's something in the reading list in the prospectus. I'm going to heroically link to the prospectus, except I can't because my chat's broken. In the Oxford MAT prospectus, I think we've got a link to a book about logic, but you know. Peter says odd and even functions is handy. Yeah, so odd functions are ones where when you reflect them in the y-axis, they go upside down. Even functions are ones where when you reflect them in the y-axis, you get the same picture back. You can write that with equations. People would like to do the quadratic equation cases. And I've just noticed the Spotify request has now got 12 thumbs ups, which is a bit terrible. Okay, good. People are doing the questions. Aha, good. I like this. Some sort of reflections. Okay, so the question here is about minus f of minus x. It's multiple choice. If you haven't seen a multiple choice question like this before, we do these on the mat occasionally, where the options are graphs and you need to choose one of the graphs. It's one of the ways we've worked out to do graph sketching in a multiple choice question. We draw the graphs. You choose which one you would have drawn if we told you to draw. Rilo's got this suggestion: draw it on paper and turn it upside down. Wow. I quite like this kind of practical approach. What do people call that? Practical geometry or something? Okay. Good. Somebody thinks there's like a rotation. Turn it around. So yeah, when Rilo turns it upside down, there's a couple of things that could mean. So it's a little bit tricky. Josh is doing a different question, but that's okay. If I turned on the right pole, if I turned on any of the poles, oh, the pole went away. The pole was going really well. Pole still going? Oh, I don't even know anymore. The poll's turned up again. If you haven't voted in the poll, here's your chance. I'm going to clear chat out. People are talking about reflections. People are talking about rotations, which is very exciting. Rotations are very tricky. They're basically not on A-level maths, as far as I know. Sort of rotations are possibly too tricky for A-level maths. That might not be true. Maybe in the end of further maths you get to learn about rotations, but they're pretty tough. Okay. Yeah, somebody wants to look at a specific point. I love that. Look at a specific point. It's the idea of my thing about plugging in 0 or something. And an easy question, somebody's asked, can you use compasses, protractors and set squares? The answer is yes, you can use compasses, protractors and set squares in that, with the current regulations if you're watching in the distant future. Rilo, if you're doing it, if you're on your phone, Rilo's got all these suggestions about ways to do this. Rotations in further maths, maybe using matrices, I guess. Okay. Yeah, specific points or more reflections. Everyone's joining in with how to do this. Somebody's asked the slightly off-topic question of what is fluid dynamics. It's exactly what you think it is, so that'll be fine. Molly's done rotations in further maths. I can't remember who's in year 13 and who's in year 12, but hey. Yeah, okay. So some people have seen rotations. We've now got like 80 votes in this poll. This is amazing. How many people are here? There are like 100 people here. Amazing. Thanks for joining with the poll. Should we reveal what the answers, what people suggested? Oh, come on, chat. You can do this. Okay. I believe in you, chat. Chat has picked C at 88%. That's pretty big all in on C, chat. I like it. Right, let's try and work out how we got there with suggestions from chat. So I saw people talking about making this out of 2 steps. To first draw y is f of minus x, and then go for y is minus that. So take the previous graph and flip it. So I guess this is a flip and then a flip, where the first flip is a flip in reflection in the y-axis, and the second one is a reflection in the x-axis. Does it make sense if you do them in the other order? I don't want to think about it. Quite possibly it does. Okay, so actually I think this one is f of minus x, isn't it? Because this one has been reflected. There's an asymptote here. Somebody suggested thinking about this kind of asymptote as an object that's moving around. So before it's at about 1, now it's about minus 1 after doing that reflection. I don't really want this though, I want minus this. Which one looks like minus this? Oh, that's actually quite a challenging thing to imagine, isn't it? But this one's going up, so it would need to be going down over here. The only one that's going down is C. I like this bit. And look, it's still got this asymptote at minus 1, and it's got the right sort of shape far away. So it is in fact C. Well done, Chad, at 88%. Good job, everyone. And good, brilliant, I love it. Okay, so putting together different transformations. I quite like this question because it takes something from the math syllabus, transformations, and then says, can you combine that with more transformations? We like combining things together. This question combines one topic with itself to give you a slightly more complicated question involving doing things moving around. Right, cool. Yeah, sorry Josh, I thought you told me about the logarithm question and then that happened. I'm thinking really hard. I think it doesn't matter what order you do the flips in. I think it doesn't matter because you could do y as minus f of x. That's your reflection in the in the x-axis, and then a reflection in the y-axis means replace all the x's. So x sort of becomes minus x. You replace all of the x's with minus x's. which will give you y is minus f of minus x. So that's all right. You can do them in the other order as well. In fact, people in chat have been telling me that this is in fact a rotation by 180 degrees about the origin. And that's true. I'm not sure if you needed to know that to do the question, but if you did know that that's how you build a rotation by 180 degrees around the origin, then nice. You can spin it round, right round, like a record, and you get this on the other side. Good. People are guessing what the other ones are, which I like. So follow-up question. We've thought maybe this is f of minus x. What's this one? This one looks like minus f of x, right? And then there are two more really weird ones, which people are trying to guess in chat. Ooh, Luke's got a rule. Order of transformations only matters if Bidmus does. Yeah, ooh. I'm scared because of the f in there as well, right? So I think Bidmus rules here is something like, is Luke maybe imagining ignore all the f's and think about what we're going with the brackets? That sort of works, because that's like thinking about the function f of x equals x. I'm not quite sure. I'll have to think about that. Good. Good. Order of the flips doesn't matter. Someone says the stream is lagging. It could be that connection, or it could be me. If it's you, if it's everyone, let me know. Cool. Good. Right. Good. People giving me like absolute values of stuff. Okay. So this is like absolute value of f of x. Have people seen this notation? So this notation, like bars on each side. That means x if x is positive, and it means minus x if x is negative. But that's a really silly way of thinking about it, because really it's measuring the distance from between x and the origin. But people always write it like sort of like this. Anyway, cool. Stream's doing all right. Good, cool. Yeah, people are getting these. Yeah, and I don't think mod's on the syllabus. We've sometimes used mod like this in questions, but explained what it is during the question. Maybe I'm thinking of other notations as well. Good, okay. Lagging from multiple people, possibly because my computer's trying to do quite a lot right now. Okay, there's a question about admissions. I'm going to do admissions chat at the end. Okay, I'm going to do what I said I'd do and jump into the middle of a long question. We haven't talked about many long questions properly on the stream so far, because normally we sort of do the warm-up, some short questions and mention the long question. I want to talk a little bit about strategy for them as well. So here's a long question. It's got different parts. We're not given how many marks each part of the question is worth, but they are officially worth some number of marks. There's a mark scheme that awards marks for them. You're allowed to skip parts. You're allowed to go down and get marks later on, even if you wrote nothing or if you got something wrong earlier on. So you can come down here and have a go at part 3, which is what we're going to do. We're going to try and engage with part 3. And quite often, the long questions have an idea that goes through the question, but not always. Sometimes there are different sections or different bits of idea that come in through the question. Okay, the stream is working for at least some people, so I'm going to carry on. One person's asked a good question in the chat that's slightly related. Logarithmic differentiation is not on the syllabus for math. I'm even going to reply. No, smiley face. Cool. You do not need to be able to differentiate log x. Cool. I mean, you need to be able to sketch log and have some idea about, hey, it's really big over there and it gets flatter over there, but you don't need to know what function the derivative is. Yes, okay, so this question is very tricky. Luke's asked about the subscript next to f, so I feel like we're going to go up to the top of the question in a moment. And is there going to be work on, will we get to work on graph sketching in any of these sessions? Oh, I was hoping we were going to do some graph sketching. I'm not sure we've got, I've picked maybe a long question that doesn't have that much graph sketching in. Maybe at some point in one of the sessions, I will need to look ahead. Good question, Maddie. The extension has got lots of interesting graph sketching that you might be interested in. If you're looking for things to sketch, why not check out the extension material? Right, that was a quick advert for the worksheet we're already looking at, so that was a bit weird. And Ellie asks about error carried forwards, which is a thing in the long questions. We do error carried forwards. Okay, good, right, okay. SV is off and away using some sort of calculator, some sort of keyboard that can type in integral signs. That's very exciting. I would like to go over here and look at the top of the question where there's a definition of what this is. I think there's a missing subscript k in here. Anyway, when I typed up the question, I might have missed a k. Anyway, we've got this definition of f subscript k of x. This is supposed to remind us a little bit, so it's a little bit like in sequences. In the very first session of MAT Livestream this year, we talked about sequences, things like A0, A1, A2, and so on. This is a bit like that. It's not really like that, but it's the same sort of, the subscripts down here is sort of labeling different things. Here, slightly awkwardly, k isn't a whole number, k is a real number. So there's a function f subscript 0.1 of x. It's just a nice normal sort of function of x. So this one, for example, would be x minus 0.1, x minus 2. But there's kind of a big collection of these with different numbers in here in the subscript and appearing here in the function. Okay, good. Computer science questions do not do question 3. So if you're a computer science question, so not for computer science students, but yes for maths and computer science applicants. Cool. Not let's go completion, not CS and philosophy. Yes, other ones. I've gone for 100% now. Okay, good. Are there emojis? Okay, good. So, a little bit complicated. We've kind of got two. It's a little bit like how logarithms have got that subscript on that means something about the logarithm. It tells you some more information. In this case, it just tells us another number, the number that we would write here. So whenever I see a k, that just means it's this number here. If I've got this complicated f subscript k of x, if that's getting confusing for me, then I can just write out this expression on the right, making sure that the thing inside the brackets appears here and here and here. That's what the x means. It means thing inside the brackets appears here, here, and here. Let's put some colour on this. Thing inside the brackets is supposed to appear here, here, and here, while at the same time, the thing, different colour, the thing under here, this k, is supposed to appear here. Okay. But this kind of gives a pattern, really, or a way to lay out, here's where you write the thing inside the brackets, here's where you write the thing in the subscript, here's where you write the number 2, some brackets, multiply all the stuff together. Did I really say if you're a computer science question, you can leave this question? My word. Right, cool. Good. Okay. I'm going to maybe go for a little, one more example. So if I want f of f subscript 1 of 0.5, so this is the function f1. The f1 function takes the value 0.5 and it would calculate 0.5 times 0.5 minus 1 times 0.5 minus 2, where I've written 0.5 in for each of the x's and I've written 1 for k in here. And it sort of doesn't matter that it's x and k up in this definition here, it's just telling me this pattern of where to write things out. I suppose this is testing when you've got a function and you plug some algebra into your function, the thing you do is you copy that bit of algebra out wherever the x would go. Okay, which is a little bit harder than plugging in numbers. Cool, and people are agreeing with each other that they're going to apply for computer science. So nice to have you here looking at question 3 as well. Cool. Good. Georgie's got a question about maths and stats interviews, which I'm going to do at the end of this bit. Cool. So CS and philosophy, no, don't do question 3 for CS and philosophy applicants. I think I hit all of them, but this P is P for philosophy. Okay. Good, right, okay. This is kind of this layout function script. This idea about, I'm really going through it slowly because this idea about that's where you write the stuff in your function is going to be really helpful for this part 3. Parts 1 and 2 are about calculus, not really on calculus today. I'm going to do part 3. Okay. So hopefully you can still see my fk of x definition at the top. Over here, we're told to verify. Verify means check that it's true, and I guess in a way explain why it's true as well. Yeah, Ollie's got this. What we're going to do is we're going to plug things in. I'm going to really concentrate. I'm going to do the left-hand side first. My strategy here is just, I want to verify this complicated expression is true. I'm going to rearrange the left-hand side, I'm going to rearrange the right-hand side, and I'm going to check that I get the same thing. Okay, so my left-hand side, again, I'm not putting numbers in, I'm putting kind of algebra expressions in. I want to take, the thing inside the brackets here is 1 plus t. So wherever I see an x in my definition at the top, I want to write 1 plus t. I'm going to put brackets around it just to make sure that I'm keeping that as one object. And then a 1 plus t in here, and then pause because I need k now. When I get to this k, that means whatever the subscript is. And here my subscript is k. Oh, that's nice. Okay, so I can put my k in here, and then the last bracket is 1 plus t minus 2. Okay, that's pretty nice. Yeah. Okay, so it's some expression, maybe pretty nice is an overstatement, but it's some product of 3 brackets. Okay, I could go and multiply this out. That's a lot of work. I'll do that if I need to. I'd like to think about the right-hand side. The right-hand side is obviously worse. So the right-hand side is obviously terrible. It's got, let's not panic, it's got a minus sign out the front. We're going to remember the minus sign. It's got a 1 minus t inside. I found that when I've shown this question to people before in live events, people are happy with the 1 minus t, because that just sort of means x equals 1 minus t. We can all imagine writing down x equals 1 minus t and then plugging in the 1 minus t's in here. People tend to be really unhappy with this 2 minus k in the subscript, because I suppose I'm asking you to replace all of the k's in the definition with 2 minus k, and if you stop and think about that replacement as an equality, then things go terribly wrong. If you think about the replacement as an equality, then it's kind of only true when k equals 1, and that's not what we're doing really. We're not really doing a substitution. We could do it in 2 steps. There's a kind of 2-step process if you want to do it like that. But I think I just want to go directly. I don't want to overdo it. I just want to write out this expression, replacing each x with whatever's inside the brackets, and replacing each k with whatever's in the subscript, even though here that's got a k in it. We're going to do that together. Okay. So we can put a minus sign at the front. I've already not forgotten it. I'm doing great. I've got a 1 minus t here for the first thing at this x outside the front. That's 1 minus t. It's the thing inside the brackets, the argument of the function. Then 1 minus t minus, right, don't panic. So this k means whatever the subscript was. The subscript is 2 minus k. I'm going to put it in brackets just to make sure that I'm treating it as that's the object. It's the parameter k, the subscript thing on this function. Okay, and then my last bracket is 1 minus t minus 2. Okay, so I've now sort of subbed everything in. Okay, yeah, the computer scientists, thanks for hanging out, computer scientists. This sort of variable replacement, the comment in chat, Yajit has said, this is a little bit like something in computer science where you're writing code to change variables or not. Cool. Yeah, and SV's got a great suggestion. If this makes you really unhappy, the idea of replacing k's with 2 minus k's, there's something you can do, which you can write out a new definition. SV's got a suggestion that we can write out a new definition. Our new definition is going to be morally exactly the same. But if maybe this is helpful to write it out like this. So this is true for any value of j, right? Because all I'm doing is replacing the k with a j. That's my first step, replace the k with a j. And now maybe I could replace the j with a 2 minus k, and it doesn't feel too strange. You know, I'm just writing out different things that are true. This is true for all j. Cool. Right. Good. Oh yeah, and by the way, doing the question, these do turn out to be the same. So these do turn out to be the same. You can rearrange this bracket is like t minus 1, which is like the negative first bracket, and then these brackets are negative of the other 2. So there's like 4 minus signs flying around, and then everything works out. They are actually equal. That's algebra to check that they're equal. I've been called out for saying morally again. and I've been called out for saying subscript. Okay, so subscript means the small letters that's kind of under, that lower down. When you've got things in chemistry or something, so in chemistry if you've got this thing up here is called superscript. Oh, spelling. And this is called subscript. Sub like below, like the subway. Script like writing. Cool. And I've been called out for saying morally, which is what I say when it's really, something's really complicated, but the underlying idea is quite simple. I use morally as a shorthand for that. Okay. Yeah. By the way, okay. Oh no, chemistry. Yeah, it's about typesetting. Don't worry, it's about typesetting. It's not chemistry. This is some number that's being it's H2 that's being cubed. Don't worry about it. It's not chemistry. Right. Good. And in some languages, there's a difference between equals and equals equals. This is like scare the mathematicians. Subway is my context for sub being below. What, instead of like the Latin roots of the words? Yeah, I think the subway is anyway. Good, right. I regret saying chemistry now. There's a sort of domino reaction of I said subscript and then I tried to explain it with chemistry and I'm being told off. I'm scaring people with the chemistry. And now I've said domino, so goodness me. Right, people would like to do the rest of this question, which is nice. I think this is probably the hardest bit of the question. Quick overview. The first two parts of this question get you to think about calculus and integration and polynomials. Because, by the way, we haven't really thought about the function at all. The function's a cubic. It's quite a nice polynomial. It's got roots at 0, k and 2. That's lovely. It's a really nice cubic. We know lots of facts about this cubic, I suppose. The first part wants you to think about writing down integrals for that area. But then the second half of the question wants you to think about this transformation. So yeah, passing arguments around. Brilliant, good. Yeah, like the sandwich shop. Yeah, Subway, like the sandwich shop. Yeah, cool, right, good. Or like this subterranean metro network. Anyway, good, right, okay. The first parts of the question are not super exciting. Maybe let's have a go at them. It's not the integration stream. It's 5:45. Oh, yeah, no, okay, let's do a little bit. So, preview of the integration stream. You've got to be really careful. Areas are positive. What we want here is this bit of area. We want to integrate the function from 0 up to k. And then we've got to separately worry about this bit of area from k up to 2. We don't quite want to add those integrals together. I want to add the areas together. I need to put a minus sign here because the integral is going to come back negative for this bit. I want the positive number, that's the area. So I need to take this thing, flip it negative. Not flip it like transformation, flip the number. Awkward, right, I'm saying flip too much in this live stream. Cool, okay, so I just want this integral minus that integral. That's my answer. Cool, good. Hot takes about sandwich shops now. Yeah, I'm going to go back to multiple choice in a bit. I haven't looked at the MAT live stream for how many. I haven't looked at the mark scheme for how many marks this is. Add the integrals but flip to the second limits. That's allowed to. That works. This is equal to the integral from 2 up to k. I'm not really sure if people know that or not, but hey. Can you use a modulus sign? You could. You could put modulus signs around each of the integrals. We know more information, right? We know that this one's negative, so when the mod signs turn up, they'll turn it to negatives. The mod sign, the vertical bar mod sign thing that we learned just now is sort of useful. If you know whether the number's positive or negative, it's almost always a good idea to switch to just, if it's positive, get rid of the bars. If it's negative, get rid of the bars and put a minus sign in, using the definition of that. Good. Is there an alternative way of doing part 3? Yes. So the rest of the question, oh, by the way, when you integrate a cubic, you get a polynomial of degree 4. Fine, okay. We get some marks in part 2. There's some fiddliness that it's got k involved in here, so we need to think a little bit carefully to check that we're getting a polynomial in k that's the right degree, but hey, whatever. Oh, by the way, degree is defined in the question, I think, or maybe not. Degree means the highest power of x, or in this case it's a polynomial of k, so the highest power of k. Good, right. Yeah, so parameters, I suppose. Yeah, that's a really good question. Can you explain what a parameter is? I think no, I can't. But there isn't really a difference between a parameter and an input. You could write this. You could write this as a function of x and k, as a sort of function of two variables, and nothing breaks. Everything's just fine. You have to make it quite clear when you're doing the integration. You have to make it clear what you're doing. But it's just a sort of, I guess, almost, it's to try and indicate that x is the important variable that we're going to think about graphing as x changes on the x-axis, and k is just some number that appears in the function, but we're not thinking about sketching it for different k. Anyway, a crucial thing to understand the rest of this question about, people who looked up the mark scheme. How does it go? It goes 2, 4. Oh, quite a bit of arguing here. I've glossed over quite a bit of arguing for that. 2 marks for the bit we've done. 3 and then 4. Okay, interesting. Yeah, let's do 4. Okay, good. Degree is not defined in the question. Awkward. But degree is now being defined by James on the live stream. Good. Good. People are arguing about parameters and inputs. Yeah, so Josh wants to know why we've put that minus sign in. I guess we're going to talk about this in the integration live stream. Areas are supposed to be positive. So when you integrate this bit from k to 2, you don't actually get the area of that region, you get a negative number. It's actually precisely minus the area of that region, if you believe that all areas have to be positive. Good, right, okay. There's a mark scheme. Okay, well, I want to stop talking about the integration part of this question. There is a mark scheme online, and we're going to come back to talk about integration in a couple of weeks. Right. Alternative people want, clearly from chat, alternative ways of doing 3 and stuff about transformations for part 4, because that's what we're going for here. Okay, which I'm going to try and do now. So, this thing looks like transformations, right? It's got a 1 plus t inside a bracket. It's got a 1 minus t inside the brackets. A key thing to do is to interpret this in terms of transformations. So the argument for part 4 really is going to be about transforming the graph fk of x to the graph f2k minus x. It's about transformations of graphs to get from one to the other. We've got an equation now, so if we've proved this with algebra, which I kind of started doing, if we prove this with algebra, then we can now talk about transformations. This thing on the left is a translation of f of k 1 unit left. Okay, so this is fk of t 1 unit left. I'm not going to write it in that gap. That gap's tiny. Okay, so we've got fk of t translated 1 unit left. Okay. By the way, that would give us a cubic with roots at -1, 1, and k minus 1. Okay, interesting. We'd get a cubic. Still a cubic. Still got roots at. Still got 3 roots. Interesting. Okay. The thing on the right hand side is a bit more complicated to interpret. It's f of 2 minus k t, and then a 1 minus t transformation has happened inside the brackets. I would think of that as translating it 1 unit left, so that gets us to f of 2 minus k 1 plus t, and then reflect in the y-axis, because that puts a minus sign on it to get us to f of 2 minus k 1 minus t. Okay, and finally there's a minus sign at the front that means reflect in the x-axis. That gets us to minus 2 minus k 1 minus t. Okay, so if we put all this together, this gives us a way to transform one of these graphs into the other one. Actually, something very simple is going on here. All that's really happening to get from fk of x to f2 minus k of x is we're getting from the case where the root is here to a different cubic where the root is 2 minus k. So it's sort of an equal distance from this side. So if we started this one with distance k between this root and k, this root here, then afterwards we'll get down to this picture with a root over here instead, and that's sort of a totally different cubic. It's got roots in different places, but it's a very closely related cubic. Someone in chat's going to tell me how those cubics are related to each other in a moment. Right, let's read chat. There's something nice and simple going on here. All of this complicated do all the transformations that are on screen still in here, it's actually describing something quite nice about the relationship between this cubic on the screen with a root at k versus the cubic if the root was at 2 minus k instead. There's some nice transformation between those two graphs. By writing it as two integrals, are you just writing the integral between 0 and 2 as two separate parts? Josh, yes I am, but then I'm subtracting the second one, so they don't quite stick together. Cool. How do you know the order? I'm just picking any order that works. I'm picking any order that works to make sense of what's going on in these transformations. Maybe it doesn't matter. I think it probably doesn't. B's got the Slido and the live stream up. Okay. Some reflections and rotations are going on. Yeah, okay, so chat is doing really well here. Yeah. It's like so these lines, this picture of where the points are, that's like a reflection in the line x equals 1. That was a terrible one. There we go. Like a reflection in the line x equals 1. The curve hasn't quite been reflected in x equals 1 because I still want it to have, you know, the coefficient of x cubed is still 1. So I still want a cubic that's like a happy cubic. In fact, what's happened is it's a reflection in the line x equals 1 and then a reflection in the x-axis. Which, even more simply, is a rotation about this point. I don't think you were supposed to spot this for the question, but the reason that all of this weird algebra works out is that the thing that's being described is just a rotation about this point by 180 degrees. So if you're looking for some sort of underlying truth about what's going on in this question, the only real fact that we're using is that, hey, if you've got a cubic that's got roots at 0, 2 and somewhere in between, then if you rotate the cubic 180 degrees, you get a cubic that's, well, it's got roots at 0 and 2, because those rotated around to get to 0 and 2, and it's got a root at 2 minus k now. When you do that rotation, you get sort of a very similar picture, and the area is the same. So that's why we get a nice fact out of this, that a of k is equal to a of 2 minus k. Because actually it's describing quite a nice quite a nice transformation of the curve. It's just being rotated. Or if you prefer to think about it as a reflection in the line x equals 1, and then a reflection in the x-axis, where the reflection in the x-axis is kind of just there to make sure that the coefficient of x cubed matches up. You get the roots in the right places if you just do the reflection. Anyway, a reflection and then another reflection. You can interpret it, if you follow through all of my translations between these two, this is like translating both of them left, reflecting it in the line x equals 0, because we've got reflection in the line x equals 0 on the syllabus. We don't have reflection in the line x equals 1 on the syllabus. So it's like translating it, reflect it, and then put it back again, and then flip it down again, and you get the same thing. Good. Okay, it's just like the multiple choice thing. Good, cool. And somebody preferred the chemistry. Cool. So I think combining the top posts together, I'm supposed to start a Spotify podcast that's all about chemistry, which I did not see coming. Right, cool. Let's do a short question. Yeah, Todd's right. You can just show the algebra is equal. You can just do the algebra. If you don't like this transformation stuff at all, then brilliantly, this question has an approach where you just work both things out. You work out a of k by doing the integral. You know, we're told what f is. We're told the function. You can just go and work out the integral in terms of k, then work out that one, and then, oh, right, okay, we're good. We're done. Good. Okay. I would always explain why for something like this. It doesn't explicitly say explain in this part of the question here, but I would still explain it anyway. Good, okay. The question does refer to k, not x, which is the input. I suppose I'm looking at this and I'm thinking about these as transformations on the input. So I'm thinking about transforming in terms of x before I do the integrals. So these are sort of after the integrals and we've lost x because we integrated. I guess I'm thinking a little bit about transforming before I integrate. let us go, just to finish up, to... I really like the logarithm one. It's 6 o'clock. I really like the logarithm one. People can probably do the logarithm one. The logarithm one's great. It's very weak to the attack of plugging in x equals 1 and seeing what happens. If you plug in x equals 1, then you're basically done with the question. So that's nice. Let's talk about this one. I'll turn on a poll. If you've got to go because it's 6 o'clock, then thanks for hanging around with us. Nice to see you. I'm going to put an ad in, which I don't normally do. I'm part of I've been at a conference today. It's been with lots of interesting maths communicator people, who sort of run YouTube channels or do outreach things around the UK or around the world with maths. They're doing a sort of maths comedy stand-up night tonight that anyone can come to. It's a YouTube live stream. So if you want to see a YouTube live stream maths comedy event, that's Clopen night, which Clopen Mike night, which is happening tonight at 8 o'clock. So if you need more math streams in your life, then there's another math stream that you might be interested in. I've put a link in the Slido, which I'm going to try and approve now. There we go. Put a link in the Slido as well if you want to come see people like Katie Steckles and other guests doing some maths entertainment. That's happening later today. I thought it would be fun. It's a thing I'm going to, so I thought, hey, anyone can turn up to that. I think it'd be really amusing if lots of people from this turned up at that. Right, cool. Good. Where are we going with this? Oh yeah, different regions. We're counting regions. Cool. If you're hanging around, we're going to do this question, and then I'm going to talk about emissions a little bit in the Spotify section of this podcast. Not podcast, live stream. Sam would like what I would write for question 3 part 2, which I might do afterwards. Okay. I've also got the solutions that come out after the live stream have got quite a big chunk of what I would write for that. So if I don't do it now, Sam, it's in the solutions, which are coming out tomorrow. Someone's been doing the Clayton Mike night, which they're excited about. George wants to consider derivatives. That's a good idea. People are still talking about question 3 because I'm behind. Could you do it with integrals from part 1? Yeah, I think you could just go back and talk about the integrals probably. Yeah, it's quite. You can just do the integrals if you want to, as an approach. Georgie's right. Sorry, you can't see chat at the moment because I've got the thing up. Let's see if I can. Last time I turned it off. Multiple choice questions. Yeah, okay. Why is it translated 1 unit left? Because it was 1 plus t inside the brackets. Multiple choice. People really want to do logarithm ones. Oh, that's a really good question. Hang on a minute. Let's look at this. Okay, voting will return in a moment. Look at this question. Really good. Is f of 2x plus 3 reflected in the y-axis? So they want f of 2x plus 3. And then, after that, reflect in the y-axis. I think that's f of minus 2x plus 3. Because reflecting in the y-axis means replace all the x's with minus x's. I might be wrong. Discuss in chat. Cool, good. Okay, poll's coming back. There you go. Oh, and I've left the voting on so you can see who's voting for what. People are voting for 9, which is nice. Can you describe in chat where they are? I don't know. Brilliant. Josh says the logarithm question is fun until you realise it's just solving the polynomial and realising the solution of the equation, and there's not much else to it. So I guess not all of the questions are 5-star, excellent, very exciting maths. Sometimes it is just polynomials and logarithms smashed together in a question. Right, okay, people I think might be typing why they've got so many regions or not so many regions. Let's try and find out. I guess this is curve sketching, like Georgie wanted. We're going to have to do some... Or was it Maddie who wanted curve sketching? Sorry, somebody wanted curve sketching in one of the sessions. Who was that? That was Maddie. Sorry, Maddie. Maddie wanted curve sketching in one of the sessions. Here's some curve sketching. I'm going to try and draw those 3 polynomials. I think this question is quite tough. We're at 74% agreeing with one answer. And the other options... Yeah, there's a bit of struggle between 6 and 8 as well. I'd especially like to know... I always want to know, if one option is really popular and you're voting for a different option, I really want to hear from you. You've got nothing to lose, and if you turn out to be correct, then you look really, you've really shown the majority of people. Right, cool. Let's try and draw x cubed. An ambitious task for 5 plus 6. I've not drawn it flat enough there. Really flat over there. Okay, that'll do. That's probably the best I'm going to get. Okay, x cubed. And now I'm going to try and draw x to the 4. I know that that's 0 at the origin. I know that when x is 1, that's 1. And I know that in between, x to the 4 is less than x cubed if we're between 0 and 1. It's a little bit awkward, isn't it? Because you've multiplied x cubed by x, which is somewhere between 0 and 1. So I think this, and symmetric. Okay, and then x to the 5 is going to be even smaller. And then through here, and then view. And then out here. Now I've got to think a little bit. So x to the 5 over here, small, closer to 0 for the same reason. I guess it's going to get out to -1. And then they switch over. It's kind of switching behaviour. I think they switch like that. Right, okay. We're going to have an argument about counting regions now, aren't we? Sam says 9. Yeah, so the axes don't count. The axes don't count as dividing up the regions for this one. We're just thinking about regions divided up by these. Okay, so this thing at the top, above all these functions, that's one region up here. And I've drawn my function kind of coming back around again, which is not best practice. It's kind of going left there again, isn't it? Not correct. Ross, oh sorry, right. I thought it was Ross again. Right has got some great inequalities in chat. I'm going to turn the Q&A. I'm going to turn the poll off just because it's going really well, because people are saying really clever things in chat. Yeah, it's all about powers. Once you've sketched these three, you've probably thought enough to sketch like any other power of x you want to sketch in there, I suppose. There are intersections over here, and you've got to be careful. X to the 4 doesn't go down over here. X to the 4 goes positive over here. Good question from an anonymous person. Do the multiple choice questions get harder as they go on? Usually yes, a bit. They're roughly sorted. 1A and 1B are supposed to be approachable and nice, and then later on in the kind of second half, we've put more of the questions where we think this one's quite tough. So there's kind of a bit of a gradient. We're not good enough at guessing how hard people are going to find them to get that exactly right. One year I wrote a question that I thought was good. It was going to be it was a 1B. We put it in at 1B, and then it turned out to be people didn't like it. I found out that people are quite bad at e to the kx. But hey, right, there's one region up here. I think there's one region over here, like a big region. And then in here, I've got a region over here and a region trapped inside here. I've got one huge region. This one's massive. This one goes all the way from kind of here-ish, all the way up here. This is all region 5 for me. Okay, and up here, region 1's huge as well. So all of this stuff. So I've got a few regions left. I've got 4 left over here. So 6 and 7 in here, and then I've got 8 and 9 out here when x is bigger than 1. Cool. Yeah, so I lure people in by saying it's easy, and then I tell the story about how I set question 1B and it was too hard one year. Cool. Did we make the questions 4 marks each to make the total 100? It is nice the total's 100, isn't it? Yeah, it was 2019. 2019, how many values of k are there such that e to the kx satisfies blah, and then hideous differential equation. Inspired by my PhD research on hideous differential equations. Ross has got a brilliant observation. I sort of wonder where people... This is brilliant, Ross. If you subtract 1 from each of the powers and then add them up, you get 9. Is that the right answer or a coincidence? It feels like a coincidence, but I'd have to do some other cases. What I would do to test that is I'd do some other cases with sort of 2, 3, 4 and see if that does the same thing or a different thing. I think about 9 feels about right for other cases as well. For the actual numbers don't feel that important. I sort of think if these were 31, 40 and 51, then it would be the same picture and the same answer. It would also be 9. So I sort of think maybe not. Like odd and then a middle-sized even number and then a big odd number. I don't know. Do we get hints in the real thing? You do not get hints in the real thing. The hints are added for the MAT livestream. Sorry, usually these blue hints. Sometimes there's a hint in the question, occasionally. There are. 2019 was the year that 1B was a horrible question by my metric of horrible question, which is success rate of people doing the question. Okay. Josh says drew it wrong but got the regions right. Oh, and somebody's got a calculus question. Find the areas of the regions. That's a great question. Yeah, so I guess I want regions. Let's rub this out. Regions 4, 6 and 7 have got finite areas that you can work out, and it's just integrating polynomials. Yeah, okay. If you want an extra exercise, I want the areas of 4, 6 and 7. You can work them out. I think they're all just fractions. Off you go. Should we test the other cases? I don't really want to test the other cases. I've convinced myself that if I put, if you want another one to try, I'd try x squared, x cubed, x to the 4 next. Because that one might be different. Might be. Not really sure. Cool. Right, okay, so do you need the middle and odd ones? Oh, Vettel was here all along. See you around, Vettel. Right, okay. I never really know if that's like people watching like Formula 1 or whether you've worked out that I like Formula 1. Never really know. If you work out the areas, I think they're just fractions. Cool. Is it always 9 regions? Yeah. Cool. The MAT syllabus is the same for computer science. People want to do the logarithm question. Come on, let's do the logarithm question. I'll put the poll up. We'll have a feel good moment together. I'm gonna hide the results. We're gonna put the logarithm question on. Here's the logarithm question. I quite like this question. So logarithms. We've got a session on logarithms. I think it's next week. This worksheet is quite long. The logarithm one is a bit shorter. Just felt like end of August, start of September. Everyone's going back to school. If you're going back to school in September, I guess. Logarithms is a bit of a shorter worksheet. I would like to know what this function looks like. And again, it's the thing where you're given an equation and you're asked to choose which one you want. The audience poll, it's on secret mode, but it's going quite well. Josh did this question about an hour ago by mistake. It's finally paying off, Josh. Did I give you the answer already? I told you how to do the question. I'm not sure I said the answer. Ali says, is the answer the total number of intersection points? Ooh. I think there are only 3 intersection points. But the number of intersection points sounds like an interesting question. So working out those. The problem is intersection points might be just 2 lines crossing, which does something to the number of areas, or it might be multiple lines coming in and crossing all at one point, which is a little bit of a special case. So I think just counting the points like that is a little bit tricky. People in chat have picked up on a hint that I said ages ago. I'm gonna have a quick check to see if you asked an admissions question earlier. Oh yeah, somebody asked, how long after MAT 2021 will I release the answers? The day after. MAT 2021 in 10 minutes or less. That's the video we make which speed runs through all of the solutions in 10 minutes. You might have seen the version for last year or the year before. That drops the day after MAT, which is you're not allowed to discuss the MAT question because of time zones. You're not allowed to discuss the MAT questions between the test date and the day after. Yeah, we'll drop that on the day after MAT. Good. Right, people are plugging in the numbers. Maybe the hint was too obvious. Sorry, SV. I didn't think we were going to spend much time on it, so oh well. It's not number of lines times the number of intersection points. It's actually really complicated the way that the number of intersection points comes into it, because of the different. Some of the intersection points are different from others. It's just all a bit of a hassle. Question 5 is a bit CS in nature. Somebody's just asked that behind this question box. Question 5 is written by the CS department. I mean, we all work together, but question 5 is written by the CS department. And sometimes it's got a robot in it. You might have noticed that they put a robot in the question sometimes. Good. Yeah, somebody's asked me. Okay, right, we'll come back to that one. How did I know to do x equals 1? Yeah, okay, so x equals 1 was the hint, maybe too much of a hint that I gave you. How's that poll going? Poll's going pretty well. We're at 94%. That's pretty good. Right, cool. I'm going to try and hide that. Good. So my hint here came from thinking about completing the square inside. Completing the square is quite often a good idea when you've got some sort of quadratic. Once you've completed the square, thinking about the minimum of that quadratic, or just thinking about the shape of that quadratic. It's got something going on when x equals 1. When x equals 1, this thing inside is 1, so this is log base 10 of 1, which is 0. Aha! I want the one that is 0 when x is 1, that's this one, that's e. So I quite like this. You sort of, if you do things like completing the square, just unprompted, without being told to go and do quadratic science on this thing inside, if you just go and experiment with it, then you kind of bump into the right thing to do, the right strategy. Good. Okay, well I don't think we've tried to cover all of the questions before, but I think we now sort of have. I'm going to wrap up the bit. If you want the full solution to this question 3, it's in the solutions document, which is the webpage comes out, the PDF version all comes out on Friday. We have run a bit long on time though, and I do like taking people's questions as well. So I'm going to take some questions now. If you're leaving because you don't want to do the Spotify bit of the podcast, of this live stream, then yeah, cool, good. Okay, we've done 4 or 5 questions today. I've lost count. Good. Okay, see you next week for logarithms. Otherwise, Georgie, your maths and stats question. It was a good question. I don't know if you're still here. Sorry, Georgie. For maths and stats, you get one interview for maths and one interview for stats. And the answer is maybe, maybe, or maybe combined. Usually one of each. I'm typing it just in case she's not here and doesn't watch the replay. But not always. Cool. Good. Right. Okay. That one. Can we end the live stream on a prime number of questions? Unfortunately, we've done 4 questions and 4's not prime. It's quite notably not prime, isn't it? Maybe we should talk about something else. I kind of want to think about this one. I'm going to have this on the screen while we do stuff. Cool. Completing the square much better than quadratic equations. Thank you, Peter. I keep mentioning the Spotify podcast now. It's really taken my imagination. Let's take that question. Have I made the Matt's already made, already off? I did call it a podcast. I don't know why. B's got a question about UCAS. Georgie is still here. Hi, Georgie. There's an unofficial Discord. It is unofficial. Sam says, is that the same for maths and computer science? Oh yeah, okay, so that thing about interview numbers is kind of the same for maths and computer science. Or maths and computer science, you really normally get 2 interviews, one for maths, one for computer science. And they might merge them. Doing things online, we've sometimes merged things that we wouldn't normally have merged to make it easier for the scheduling, and so that once we've got you doing the maths bit and then the computer science bit, I know a couple of colleges experimented with doing those kind of back-to-back, so that there would be one slightly longer interview that covered both things. Next week's live stream, Adam, is on logarithms. We're going to talk about, if you liked that logarithm question, we've got more logarithms coming up next week. 4 is a prime power, says B. Yeah, good. Can I pay for early access to MAT questions? Maybe I shouldn't even read these out. Good. Right, logarithms. Good. Emmanuel's found all the areas. There you go. It's appearing. Here it comes. Oh, prime number of questions in the chat. Because it's at 344 or something, Matt. Right, cool. A good question is, can you discuss the similarities between the graph of the quadratic and the graph of the log of the quadratic? The logarithm is an increasing function. If you have a bigger number and you get a bigger number out, that means that when you have the logarithm of quadratic, the bigger values of the quadratic give you bigger values of the final answer. Now, the logarithm's tricky because you shouldn't put negative numbers inside your logarithm. So there is trouble with, you can get into trouble if your quadratic goes negative for some region, then your graph might be undefined. Logarithm of quadratic might be undefined where that quadratic's negative. But those are really the only 2 things you need to know. careful where your quadratic's negative, and otherwise the logarithm gets bigger as you put bigger numbers in. Good, okay. Yeah, good, okay. Yeah, so someone's looked ahead. Okay, let's do this one. This has just come in. There's no chapter for prime and recursion in the A-level book. Primes and recursion are the sections at the end of this live stream, weeks 8 and 9 or 9 and 10 or something like that. At the end, I've put them in. There's nothing in the MAT syllabus on them, but quite often we've noticed bits of questions here that aren't actually using anything from the MAT syllabus. And I wanted to put those questions into the MAT live stream as well because they exist and they don't use anything from that live stream. I've kind of loosely grouped those together into recursion as an idea and primes and proof as an idea. And there's a bit at the start on revision or warm-up exercises, which might be more important for those ones if you want to practice some warm-up questions with those material. I'm not expecting you to have studied recursion because it's not really on A level. Right, cool. So those ones are going to be a little bit different because there's no MAT syllabus section at the start, and we're going to look a little bit more at the content and the way that MAT questions use new material. Good. Okay. I can't work out how to turn this off. There we go. Good. Yeah, we did this one. Maths and computer science. Cool. Okay. Okay, I'm approving questions. I'm going to spend 2 seconds to put together a group of questions. Choosing colleges is in there. This one's important. The sessions between them do cover all of the maths in the MAT. We're going through the syllabus in reverse order. I don't know why that was a good idea when I started, I suppose. We're going through exactly the MAT on the syllabus, so that the MAT syllabus section at the start, by the end of this, will have covered exactly all of the MAT syllabus, working backwards. I wanted to do sequences first, don't at me. Right, good. Yes, okay. Primary recursions again. Good. Yeah, second derivatives. Yeah, second derivatives difference. Riley wants to talk to B. Primes. Okay. All interviews are online this year for Oxford in 2021. We did all our interviews online last year, and they're all online again. Good. Okay. Rilo and B, there you go, cool. So computer science students, I'm trying to pick out the easy questions as I approve them in chat. Computer science students don't do questions 3 and 4 on the MAT. You do questions 6 and 7 on the MAT. The long questions are still worth 15 marks and the short questions are still worth 4 marks. Right, cool. Loki's got an interesting question. What's the lowest MAT score I've seen that has been shortlisted? Which is 0. And because we occasionally shortlist people who didn't do the MAT, so 0, I guess. What's a good score to aim for? I usually say 75. 75 is pretty good on the MAT. Sam would like to know about 4th A levels and EPQs. So I guess Sam knows that we don't use EPQs or 4th A levels in Oxford admissions. But I suppose if you've got the opportunity to do either of those things, then either of them could be a way to explore more academic study. In terms of your application for Oxford, doesn't matter. We're going to look at your MAT score. If we shortlist you, we're going to look at your maths questions at interview. If you've got the chance to do a maths-related EPQ, that could be really nice as a way to explore maths yourself, which is something I personally encourage people to do. I don't think it matters. If you can't do an EPQ on maths, then oh well, never mind. But hey, you could do some fun stuff there, I think. It depends whether you can do a mathematical EPQ. I know that they're a little bit tricky on that because they're normally essay based. And 4th A level could be anything, right? So it could be a subject that you really want to study. So I think that's a question for you and teachers. You don't have to do it to impress me. That's always nice, isn't it? If you can do something and you're not explicitly doing it to impress some random person on the internet. Right, cool. God, the internet is so weird, isn't it? Here we are. Right, okay, good. What am I doing? So person that you've asked this question a few times, and I will address it. Let's go. You're applying for maths and computer science. Do not have a background in computers. Will computers questions be asked in the interview? So, maths and computer science, not very interested in computer hardware, not very interested in computer architecture. They are interested, not very interested in the hardware of computers. They are interested in algorithms and solving problems with computers. And these days they do expect people to have at some point had access to write some sort of code. Maybe on one of those internet web browser, sort of, you can write code, you can do sort of little bits of learning to code and writing bits of code online now, even without installing anything. So we think most people applying for maths and computer science have had some experience of getting computers to solve maths problems by just checking lots of numbers, which is very satisfying if you can get it to work. So I guess we expect you to have some idea about working systematically, because you maybe thought about working systematically in a way that you can explain it to a computer. And for complicated problems, it's not obvious what working systematically means. I'm doing this with my finger pointing along a number line, but real problems are more complicated and have more dimensions than that. So that's an important skill. Actually knowing about computers, like the physical objects, computers, not so important. Good, right. Good. Am I doing online? We're doing a little bit of both this year. So if you're applying for 2022 entry, let's hope that's all normal. 2021, we're doing a little bit of online teaching and a little bit of in-person classes. The tutorials, the small group teaching is mostly in person and has been for a while. So, yeah, cool, good, okay. How are we going to be asked to draw a graph in an online interview? We've been using a kind of online whiteboard. We used this one that I'm in now called Miro. We used this one last year. Haven't confirmed yet whether we're using this one again this year. It's not tricky. You don't need to learn to use the whiteboard in advance or something. If you can access the whiteboard, then we can write on something like this together. But it's just like if you've got access to a web browser that can open this up and you can draw on this. Having some sort of tablet or a phone or something you can poke to draw on is a little bit easier to read, but if all else fails, then in remote interviews we've fallen back on write on a bit of paper and hold it up to the camera, and that works better than you might expect. Cool, right, I am so far behind. Ooh, yeah, cool. Proofs and conjectures. If I got any books. EPQ on your personal statement. So for Oxford it doesn't matter that much because we've got things like MAT as well as EPQs. If you've done one and you've thought about maths a bit, then hey, why not tell us about maths for that? Yeah, I think I know you've got a character limit, but if you've done an EPQ about maths, might want to talk about that. Which parts of the syllabus? Oh, I see. So no, you need to know the whole syllabus if you're a CS applicant. Sorry. I'm going to make someone's day here. Oxford applicants do not need to do STEP. Smiley face. James, there you go. That's probably made someone's day, right? The news that confused about STEP. When do we do STEP? Great news, Oxford applicants. You do not need to do STEP. Good. Yeah, so when I say 75 is good, do I mean anything below that's bad and anything above that would be around average? No, I kind of mean, people ask me for a number, right? But kind of there's a distribution around, maybe I'll go back to saying 70 to 75 is kind of good. I don't think it's bad below 70. We've shortlisted people with math scores below 70, definitely. There's no hard cutoff. It's not pass-fail. It's your score is your score. More the better, please. Good, okay. MAT is the main thing we use for shortlisting is MAT, the Maths Admissions Test, the thing we're talking about. Why don't we make the MAT harder? We don't really need to make it harder. It's doing its job at the moment. And if you make it harder, it's much more stressful for everyone. So, because we're nice. There you go. Could maybe make it slightly easier. Anyway. All right, here's a list. Cool. Let's have a look at this list. How important the following factors for Oxford admissions. Interview and MAT, I'll put joint top. I'll put those as very important. But hang on, predicted grades, if you're not predicted to make the standard, so predicted grades is very like, if you're predicted to make the grades, congratulations, so is almost everyone else. If you're not predicted to make the grades, that's quite worrying. If your teachers are predicting that you won't make the grades that we're looking for. So maybe that's important, but actually when we're making admissions decisions, it's not important because everybody is already predicted to make the grades. So predicted grades unlikely to be important for you because you're probably predicted top grades. Teacher references have some useful information. Personal statement has some useful information in. Your GCSEs, this year we know that people didn't really sit GCSEs and the scores are all a bit different. Yeah, okay, roughly that order I think. Math and interview, top billing because they're maths. Predicted grades has got some maths information in there as well, especially if you're not predicted to make the grades, which sounds like the wrong way around, but hey. And then personal statement and GCSEs. Oh, I missed teacher references that way around. Good question. B's off, right. Cool. There's a classic. Okay. Oh, how would I sketch sine x over x or x over sine x? Those are tricky. Those are in the extension. I think I would try some values, not 0, but I would think about so x, sine x over x. I would think about what sine x oscillating between. Sine x kind of oscillates, but it's trapped between 1 and -1. So I might try and write down some inequalities. And I might try some special values where I know what sine x is doing. 1 over x is quite, I know what 1 over x is doing. Sine x I've got to think about. I'd try some values, not 0. And yeah, good. Right, cool. People are recommending Project Euler, which is brilliant. I don't know about interviews in 2022. So this question about it's not appearing, there it is. We don't know yet whether interviews will be in person in 2022. I just generally think anybody who tells you anything for sure about December 2022 is, I don't know, just got some sort of incredible future seeing powers. Cool, summer schools. Molly wants to know about summer schools. Rilo and B are still trying to find each other. I think B's gone now. Sorry. Molly's personal statement is down to the character count. Yeah. Okay. Right. So this question confused me the first time I saw it. Here we go again. I mentioned somewhere where you discussed applying one question technique to other questions. So it's hard to figure out how to apply some math again in a different way. I can't remember what you said. I can't remember what that was. Sorry. I say a lot of stuff. Applying one question technique to other questions when solving questions, I guess. No, I can't remember that. Doesn't ring a bell. Sorry. Oh, right. Okay. Right. I'm missing questions, and then people are asking them again, which is making me nervous because I'm getting more questions. Okay, I'm going to try and catch up. Step exam practice is good for maths. I'm not trying to throw shade at Cambridge. I was at Cambridge for 8 years. I like Cambridge. These ones will cover all the content. Somebody wants to know, was it 70-75 or 70%, 75%? Maths out of 100, so those are the same thing. Don't forget to end on a prime number. Oh, goodness me. We've just gone past 400 on questions in the Slido. Got to end on a prime number. Okay, bye, Sam. Advice for gap years. Advice for gap years is on our website. If you look up Oxford Maths Gap Year, in short, you can apply. You should have a plan for what maths you're doing to be prepared, but if you're prepared for university, then it shouldn't be an inherent disadvantage. Emmanuel wants to know about the maths and physics 4th year, where there's a 4th year master's course called Maths and Theoretical Physics, where you get to do some theoretical physics combined with really tough mathematics to explain things like general relativity and other branches of modern theoretical physics. Is really exciting. If you're the sort of person who can't choose between maths and physics, then possibly this is the sort of master's level course that you'd be interested in, where you get to do really hard maths and use it to understand the kind of modern physics that you hear about a lot. It gets mentioned as kind of quantum theory, but you get to actually know quantum theory and do things with quantum theory using your incredible math skills. It's really good fun. There's a page about it somewhere. If you search for Oxford Maths and Theoretical Physics Masters, if you search for that, you might find their web page, which has got more information about what courses you can do at the moment as part of that master's course. It changes a bit. They're trying to keep it modern. Good. The classic question in here as well, what sort of things on a personal statement would make you shortlist on with math scores below 70? We're looking at context around applications. We're looking at the context in which you've achieved previous academic achievements, and we like to look at people's achievements in context as well. That's, I think, the best thing to say there. Good. Nobody's personal statement is bad. Nobody's ever written a really bad personal statement. Good. Right. Why do fewer people apply for the joint maths course as opposed to just plain maths? It's interesting, that, isn't it? The joint maths course do have fewer people. I think more people want to do lots and lots of maths. I don't know, or lots and lots of pure maths. I don't know. I get the feeling from chats that we have in here that pure maths is really, really popular, and people want to do lots of pure maths. I don't know. Good. That's the same question I've already got, but asked by a different user. Cool. Right. Cool. I've already done that one. Someone starting sixth form. Good. You're doing 4 A-levels and EPQ, my word. Okay. Last year's MAT was quite high scoring. Do you reckon this one might be tougher? I've said a few times today, we have a really hard time judging exactly how hard people are going to find the questions. So no comment. What was it like doing 4 years of a maths PhD? It's really good. I got a chance to do some actual maths that was mine. So there's now some maths out there that I did. It's like my maths. And after years of learning lots of other maths that other people have done, it's really nice to think that there's now just one tiny bit of maths in a very, very small field, in a tiny corner where nobody else really goes. There's a little bit of maths that's mine. It's great. A lot of work though. And that was a summary of 4 years of my life. A star in further maths is highly recommended. We almost always want people to have A star in further maths if they're doing further maths. If you're changing from another university, if you're applying from another university, it's not about age, it's about changing courses. We don't do transfer from one course to another course, so you would be applying to start the course again, start from first year, which might not be what you want. Also, we would like to know why you want to stop that course and start this one. So you could tell us about in your personal statement why you're doing this. Good. If you want to be a theoretical physics, it means it doesn't really matter if you do maths or physics. This is the conversation before, because if you've done maths or physics and you've taken sort of mathsy sort of physics, or you've done mathsy sort of physicsy sort of maths, then you can apply to do things like a fourth year in maths and theoretical physics. The master's course that I talked about, stream lag, I talked about a while ago, which I'm very excited about. Do I recommend any books about fluid dynamics? Not really. It involves a lot of partial differential equations, which you learn about in the first year of a degree course. If you want a book for when you're on the second degree of a maths course, if you're on the second degree of a maths course, then I found the book by Gray Worcester very useful indeed, which I think is called Introduction to Fluid Dynamics. It's a very small book, it's very good. But you do need to know some partial differential equation stuff first, sorry. It's one of the reasons the first year in a maths degree is usually quite fixed. You need to learn these things, and then second year a little bit more options to, do you want to learn about fluid dynamics now? Here we go. We already told you about all the partial derivative stuff. Good. Have similar maths and physics courses? They're quite similar. They're quite similar, got some similar content going on in there as well. But taught in slightly different ways. And you should also think about, as well as the ways that are similar, the degrees have got other stuff in as well that isn't related to the overlap. So like on the Venn diagram, you've got to think about the outside bits of the Venn diagram as well. Good. Here's a nice question. Still going, here we go. Okay. Can anyone watch lecture of other subjects at Oxford? Maths student go to physics lecture? Yes. Oxford students are actually allowed to go to lectures from other courses. They don't get the exams in the other courses, they don't get the degrees, they don't get the tutorials, the kind of small group teaching, but they're technically allowed to go to lectures for other courses if they want to. In practice, it's a lot of time commitment, people are quite busy, people don't normally do that, but technically have access to lots of education. Cool. I'm really sorry to Rilo and B, who I sometimes, because I'm being very short, very bad at keeping up with chat, they're failing to meet each other. I think B might have gone. Good. Right, hang on, here we go. I'm going to make this person's day as well. Here we go. A position in maths, like a place on the course, right? You do not need any research experience to apply for maths at Oxford and make a competitive application. Supercurricular knowledge means other bits of maths that you're interested in, which we like to see, because we like to see that you're interested in other things. That you know, when we show you 3 years of maths degree featuring new maths, you'll be interested in learning new maths. But you don't need to do any research or work out new things. It took me like 7 or 8 years to get to the point where I was working out new things. Technical admissions question. I love it. What's our cover ratio? Emmanuel wants to know. Our cover ratio is about 1.1. We make slightly more offers. Oh, hello. Yeah, slightly more offers than places. Last year we trimmed it a little bit because we thought that people were going to make their offers more this year, and we were correct. So normally we make slightly more offers than we have places. Sometimes people turn us down. I know. Sometimes people turn us down, so it's good that we made slightly more offers, because then a few people say, actually, no. Sometimes we think they've got other universities going on. We don't take it personally. And sometimes very rarely, people miss the grades. This year especially, very rarely. Good, cool. Do I think that, so PhD chat sometimes leads onto this chat, right? Do I think that doing a PhD and then teaching maths at university is a good goal to have? Look, it's your life. You can have any goal you want in life. If you want to aim there, I think that's like aiming for like the top of doing maths, teaching maths. I think that's a really good ambition to have. It is quite ambitious. There are more people who start the maths degree than who end up in that position of teaching mathematics. It's quite competitive. It's quite a hard job. It's quite a lot of work. But if you want that, if that's your ambition, then don't let me take that away from you, right? I'm not going to take it away from you, but you shouldn't let me, even if I was going to. Cool, right, good. Whew. It's a very stressful job of being a little square on the internet, which is what I'm doing. I'm being a square on the internet, but don't let the square on the internet tell you what to do. Right, okay. If you have issues, I've missed so many questions, sorry, but you're asking really good questions, so that's good. If you have any issues during your A-levels, if that wasn't already taken into consideration for your A-levels, then you could tell us about that on your personal statement. I guess, yes. Yeah, if there were like issues around your education, if you had to miss a chunk of A-level lessons for some reason, then maybe let us know on your personal statement, so that could be a bit of context. Right. Let's make Harsh's day as well. So you don't need backgrounds. You don't need previous knowledge about philosophy to apply for CS and philosophy. You do need to be interested in CS and philosophy. And that's the intersection between computer science and philosophy in particular that you should be interested in. But you don't need to have previously studied it. Good, right, cool. Emma Rule says they're doing physics and further maths, and they're worried because sometimes we would like to see people doing 3 subjects at once. If you're doing further maths in a single year, that's a bit like the people... Yeah, no, hang on, this is fine. If you do maths in year 12 and then further maths in year 13, that's fine with us. We think about something like 10% or maybe 25% of people do maths then further maths like that. Fine with us. You're doing further maths in a single year. That's like twice as much work as doing things in parallel. It's really hard to explain this to other subjects, but anyway, you're fine. It's good. Fine with us. Right, good. If you choose maths and CS, you're missing out on some of the sort of differential equations, fluid dynamics sort of stuff, some of the theoretical physics material you miss out on. You do more of the pure theoretical mathematics, and you miss out on some of the differential equations sort of stuff, the stuff that I love the most. Good, right, good, okay. I don't know TL maths, but good. I'm actually gonna... BM Rilo, you've got to find a different way of meeting each other, because I'm not comfortable putting it in the stream forever. Cool. Right. Please remember that things you put in the Slido are embedded into the stream. Right. Cool. I don't know if you do CS and philosophy. No, I don't know. Sorry, I don't know which bits of computer science you miss out on. Sorry, it's sort of 2 steps removed from the stuff that I work on that I'm interested in. Best maths books to read. There's quite a lot recommended in our prospectus. Let me put a link to our prospectus with kind of different styles and different topics. So I'm going to link you to a few. See some suggestions in. I don't know why. Sometimes I type the responses and sometimes I say them out loud. But hey. Okay, let's go back to questions I missed. Yeah, sorry, Vicky. Choosing colleges, Ronan. Oh wow, and Molly's got an actual practical suggestion here as well, which I'm going to read out. So for the people watching the stream back afterwards, Ronan's asked advice on choosing a college. I usually say something like, every college is the best, they all have access to exactly the same maths degree. Molly has put a comment underneath that you can't see on the stream. Molly says that they looked at the 360-degree tours of the colleges, which you can find on the web if you search for 360-degree tour Oxford colleges. They're free, they're there, you can look around online. And Molly says that they made an Excel spreadsheet looking around the colleges. So that sounds fun. Good, okay. This question, does the teacher's reference needs to include info about the school's background information? We recommend it if possible. Schools have got quite good at putting a kind of couple of sentences or a paragraph at the start explaining key facts about the school, sometimes with a link that they want us to click on to find out key facts about the school. We also get some statistics from the government about England's schools in England, about statistics about those schools, so we get some information, but in general we're fans of information, so that's good. Good. Let's do a couple more. Riser's off. Bye, Riser. Belinda wants to know, does the college you apply to affect the topics you get in the interview? No, we're all going to ask you maths questions if you apply for maths. So in some sense, just no. We're all going to ask you maths questions. We ask different questions to each other. We don't all ask the same question. So I suppose you get different questions. So in some sense, yes, we're going to ask different things. But it's not the case that it's not people asking about their research. I don't ask people about fluid dynamics, and yeah, people don't just ask questions about their own research. People ask about fun maths that's related to stuff that you know about. Cool. So in some sense, yeah, because we ask different questions, but in some sense, no. Loki, good excuse for an advert. I've done interviews before. I can remember the questions. There's an interview session. We're doing it. I'm going to do it after the MAT. But this MAT live stream will keep running for a few weeks, and we'll do a session on interview questions later on with some of the questions that I've used before in interviews. So that'll be fun. Good. Good. Okay. An anonymous person has gone A in further maths. Meet required. So A star in further maths. When I said that earlier, oh dear. When I said A star in further maths earlier, I was thinking about the maths degree. I'd forgotten that we got maths and computer scientists here. That's fine. Sorry, if you meet the requirements. It's been a stressful day to be a square on the internet. If you meet the requirements, that's fine. You did it. That's what you needed to do. Sorry, I forgot that for maths and computer science there's a different standard conditional offer, a different bit of text. Sorry if I confused you before. I was thinking about maths when I should have been thinking about maths and computer science as well. Okay. Hi. How many people till date have got 100 in the maths? That's just come in. We don't keep that statistic. Advanced topic personal statements. So yeah, let's do this one. Okay, I'm almost up to speed with chat. I've only got 30 questions to go. I'm sorry if your question's waiting in moderation for ages. It's because I'm reading things. Right, quickly, let's go. If you write about hard topics in your personal statement, that's probably not going to come up in your interview. We don't make up harder questions just because you've told us about harder maths in your personal statement. No. We're probably not even going to ask you about the things in your personal statement. Sorry, we like asking people about surprising new maths that they weren't expecting to see. We don't like letting you choose what to do in the interview. We've got ideas about what questions to do, so sorry. Not CBSE, can I apply to Oxford with a high MAT score? So we would like you to have some qualifications that are equivalents to A-level. There's a big list of international qualifications that you could look into. You can apply otherwise and take the MAT. MAT's still interesting to us, but we do need to know that as well as after MAT. So MAT's got very limited maths. As well as MAT, are you going to learn a kind of appropriate amount of maths that's comparable to A-level maths? Suggestions of how to do that are the different international qualifications that we do accept. Okay, that's a very technical question, sorry. Good. Ali has done some step questions for fun. Brilliant. They're quite interesting and difficult, yes, and they use a lot of maths. How would I suggest approaching hard math questions? So steps are useful because the questions are really hard. You can get stuck on them. You can think about them. They've quite often got an idea that goes through the question. They're a bit like the math long questions. They do use lots of different maths topics. So yeah, if you haven't started sixth form yet, then you might find that you haven't learned some of the maths you need to yet. Okay. Georgie has got a question about ratios. Georgie wants to know the ratio of people getting an offer as a fraction of people who got an interview, or the people who are getting an offer. So, the first one is about 30%, and then the second one is about 33%. So the first one, but they're kind of about the same. Wow, that's maybe the most mathsy admissions question I've ever been asked. Like, it's like a comparison of which is bigger, A over B or B over C. Oh, okay, brilliant. I like getting asked maths questions. This is good. Here's a question about plagiarism, but probably not actually a question about plagiarisms. The question is, what happens if there are personal statements that talk about very similar things? That's fine. You're allowed to be interested in the same things as other people. If you type the same sentences as other people, then it's a bit suspicious and looks like plagiarism. And I think UCAS, the admin people who do the forms, will get in touch with you to say that they've noticed your personal statement is the same as somebody else's. But you're allowed to be interested. That's fine. You're allowed to be interested in the same sorts of maths as other people. Right, cool. Do you get MAT scores back? Yes, applicants to Oxford get sent an automatic email in January at the end. Once this is over in January, we send an email to each Oxford applicant with their MAT score to tell you how many points you got in maths. Cool. Can I do differential equations in a maths and CS degree? You can go to the lectures technically. Like I said before, you can go to the lectures if you want to. I don't think you can get that to count towards your maths and CS degree. And we're talking about the advanced, like the next thing that's coming up in differential equations. So even if they're your favourite at the moment, you might find the more advanced stuff might be a bit less like the sorts of maths that you're interested in anyway. I don't know. It is hard choosing between courses because you're sort of choosing between what options you'll have later on, which can be very tough because you don't know what you're going to want to choose. I recommend maths and CS for people who are interested in both maths and CS, which is not helpful advice, but it does sound like helpful advice. Cool. Or maybe the other way around. Yeah, the number of... Yeah, okay, here we go. Here's the maths thing. Like the number of applicants at each stage, roughly geometric progression with r equals 0.3. But that changes. The number of applicants keeps changing, so it's kind of ruining it. Cool. If you want to do maths and computer science, but you didn't do computer science at A-level, that's fine. You can include CS by telling us about problems you've solved by writing very small bits of code for a web thing or for a compiler if you've downloaded something. If you've learned a tiny bit of C or Python or something, then you could tell us about that. Or you could just tell us about solving problems systematically and how interested you are in algorithms. Something like that. If you, so we expect people to have some experience of messing around, like trying to use computers to solve code, to write code to solve problems. Even if you haven't done computer science A level, which you don't need to do. Gap year disadvantage. Scholarships. So most scholarships, most of the scholarships do depend on the admissions process as well. We do admissions first, and then we sort out scholarships. And where there are limited scholarships, we tend to award them based on eligibility, but then within that, based on performance during the admissions round. So in some sense, yes, scholarships depend on everything that's happened before. When we're deciding who to award scholarships to, we've got limited scholarships, and we partially do that based on admissions measures through the process. Quite technical again. Does interviews, hey, let's make Belinda's day. Does interview time take into account the different time zones? Yes, a bit. No, right, so yes, if you're on a time zone that's very different from Oxford, then yeah, we think about that very carefully, and we make sure that we're doing your interview at like a time that's kind of daytime for you, like during the day. No one has to do their interview in the middle of the night. If you're in a time zone that's quite similar to London, if you're in like the middle of Europe somewhere, then we're not aiming to do everyone's interview at 9 o'clock or something, so you might be out by an hour or two. Is MAT scheduled to avoid clashes with major exams of particular countries? No. Sorry. If you've got 2 exams on the same day, then you do one exam and then the other exam. I'm really sorry, we can't avoid all of the exams in the world. It's 4 a.m. right now. Yeah, we're probably if it's 4 a.m. for you right now, then we're probably going to schedule that carefully and not do it for 4 a.m. Right, cool. What am I doing for dinner? I think we've got some sort of curry tonight. Brilliant, cool, good question, thanks. How difficult is it for international students to get scholarships? We don't have a lot of scholarships for international students, and I don't know anything about a loan program for international students from UK banks or organisations. You might be able to find things. You should start looking now, I suppose. Yeah, and interviews for CS students involves some maths and maybe a little bit of understanding, solving problems systematically. Right, okay, final stretch. I'm going to try and clear up as much as I can before we hit 7 o'clock, when I am going to stop and eat dinner. Before Clopen night, Mike night at 8 p.m, which I might see some of you at. Cool. Didn't do CS, have an EPQ. Is that enough? That does demonstrate some interest in computer science, I guess. Tell us about that. Cool. And there's that question again. Not applied to a maths degree to other universities. Okay, maybe personal maths. Is it okay to talk about maths and physics on your personal statement? Yes, that's fine. There's the thing about following factors in some order. Ali would like books about proof. I don't have any off the top of my head. Drawing graphs, maths, EPQ. I'm getting there. I haven't done Olympiads due to the pandemic. That's fine. Not everyone's done Olympiads anyway, and there's one way of being interested in mathematics. Hopefully you found some other mathematics to do instead of Olympiads. Other bits and pieces to be excited about. Whiteboards, colleges, overseas, in an overseas uni. So I think I mentioned before that we want to know why you're changing courses. We don't do transfer, so you'd be applying to start from the start of first year. Almost there. Quadratics. Apply as an individual student because you didn't have a UCAS buzzword. I'll type a response to this one, I think. Lowest MAT score again. And then, yep, cool. I can't give you financial advice on accepting loans. Please do not take financial advice from me. Fluid dynamics, logic, maximum minimum polynomials. Do we log differentiation again? Once wants to get an interview. Last question. Once we get an interview, is the interview the only factor affecting the final decision? No, we look back at your whole application, including math scores and everything, because we can. We've still got all of that information. We love using information. So that even if you had a bad day on the interview, we could maybe say, oh, this is interesting, but we did say they got a really good math score and they're very interesting on the application. But yeah, maybe let's schedule another interview, or if we don't do that, then we still can make that decision overall, not just final hurdle. Was it last week I tried to explain the hurdles? Cool. Engineering, right, cool, good. And let's actually stop on this one. When you first did these just chatting sessions, did you expect it to be a full hour? No. But it's been lovely answering your questions. There's a couple I haven't done because they're very personal questions that I think I'll type a response to rather than reading them out on the stream. But otherwise, I'm going to wrap up now. Thank you for joining in. Thank you for asking all the questions that you asked. Solutions get posted tomorrow. Have a nice evening. See some of you for Clover Mike night. Take care. Goodbye.